A customer sent in their Frigidaire controller board for us to fix, and it seems to be having some issues with the oven feature not functioning properly. And for those of you who don't know me, my name's Nick. I started Nick's Electronics Repair over a decade ago, and since then we have fixed over 26,000 devices. Now the first thing I like to do with these controller boards is remove the top portion of the circuit board, because often we can quickly find some damage on the backside. So to remove the top portion of the board, we actually have to pinch and remove this little clip. There are two of them. And then we can go ahead and pinch this clip together. And this one. Now we're gonna have a little resistance because of this connector here, but you're just gonna push through a little bit and then it'll release, and then we're gonna wiggle it out. And here we are. And now we're gonna take a closer look on the back over here. So for this part, we're gonna switch over to our microscope. And on the back side, I wanna show you the back of this large relay here. This one is the one that most commonly has issues. If we take a look here and here, our joints actually look really good on this one. However, our joint over here doesn't look as good. It looks like we have a little ring forming around the joint, and that usually is going to be what we call a cracked solder joint. So that is going to be a joint we're going to want to reflow. Now, something else we'll notice is that it connects to this pin over here, which goes to this pin over here. And if we flip it over, that's going to be our resistor R1. And we're going to want to make sure that it's registering 220 ohms. The reason we want to do that is because that resistor is known to commonly fail with this circuit board, but usually that's when one of the relays fails. And sure enough, we are getting our 220, so we're good there. I do want to also inspect these joints here. These are going to be the actual connectors for the in and out for the high power to heat up the heating elements. So because of that, those are prone to getting cracked joints. But right now it looks like all of them are in pretty good condition. I don't see any reason for them to be defective. Over here we have another one. And here is our power in, LX. That's going to be our black wire and for power. And it looks like we might have the beginnings of a crack. I don't think that that's actually going to be an issue there, but we're going to want to definitely touch that up. Now these joints over here are for our relays. And those look okay, I think. They could be beginning to crack, so I would say for those, we're probably going to want to touch them up as well, but I don't think that that's going to be the reason for our problems here today. Okay, the last part I want to check is this connector below all of these relays and the relays themselves. Okay, and I think we just found the source of our problem. So this one is a joint that is very badly cracked. That's actually really in really bad condition. So I just grabbed that connection with my pliers and I'm giving it a little bit of a tug, and you can see that that pin's actually freely moving inside of that joint. So that pin is actually fully disconnected. It probably is making slight contact when it's, shoved to one side versus another. But this is gonna be for sure a confirmation that that pin is the reason for our faults. Looking at the next one over, this one is a no connect, but it is definitely getting cracked. Let's see, this one over here. So actually all three of these, but this one over here also is starting to get a cracked joint. Same with this one. This one's pretty bad, and this one's also very bad. So that's just a quick visual inspection that I like to do on all of these boards. Now, with everything we found out, I do believe that if we just and only just reflow the pins on this connector, this circuit board will work again and the oven will be operational. However, that's not what we're gonna do. We are gonna want to always give the royal treatment to every one of these circuit boards. And the reason for is because if I only do this repair, then this board might fail again in the near future, maybe a year, 2 years down the line. And like I said, we do commonly see cracked solder joints on the back over here where these relays are, where these connections are. So we're gonna actually reflow the entirety of this board where all of the high power connections connect to and for all of the relay pins. This is the only way that we can guarantee long-term success for these repairs. All right, we're gonna start by adding some flux to some of our joints here, starting with that connector that we found all the damage to. And we're also adding a little bit of new solder. And then we're going to give that a quick clean with isopropyl alcohol and a Q-tip. Next, we're going to be reflowing these relays that are next to the connector. Same thing, quick cleanup. Now we're going to scooch over to our larger relay. Again, same thing, we're going to add some flux to our joints. Now for some of these larger pads, I am hanging out on the pad for a little longer and on the pin for a little longer, and that's because I want to make sure that we have very good contact and heat transfer between the soldering iron, the PCB's pad, and the pin of the relay itself. And again, this is one of those areas that we commonly see issues with, so we definitely want to make sure we have a good strong bond with that solder. Yeah, we'll add a little bit more flux to these joints. And finally, we have our last joint over here. And finally, we have our relays here, but I'm actually not going to touch up the solder there. These are these two white relays over here near the end. So I guess they are labeled K5 and K3, and they are 0Z-SS-112LM1F relays. And what we're going to do is we're actually going to replace them. So the reason we're going to do that is because this larger black relay I have actually never seen go bad unless there's actual physical damage inflicted on it from a bad joint. The white relays, however, over here, those I have seen fail internally. I have already live tested them in circuit, but because I fear that they might fail in the next year or so, we're going to go ahead and replace them anyways. Again, this larger black one we're not going to replace. I've never seen these fail. I have commonly seen these fail. So just as a preventative repair, we're going to go ahead and replace them because I do believe they're most likely near their end of life. Now, ironically, for removing them, I do like to add some solder on the joints first, and that's because that'll give me a little bit better flow and make it easier for the removal of the solder. Just reflowing, adding a little solder everywhere. I'm not adding extra flux. There is extra flux technically already in the solder that I'm using, but I don't want to put extra solder or extra flux because otherwise it might actually start clogging my desolder pump. That's not good. Let's do that again. That's much better. I think we can do better there. That's much better. Same thing, the last couple of joints there seem like they still have a little solder. Oh, that was weird. Screen went black screen. Yeah, we're still good. Okay. And we have another set of joints holding in the relays here. Same thing. Gonna add some extra solder, get some good flow. Still a little solder right there. Okay, that should be good. And now our relays should actually be free and come out. And they did. For those of you who are interested in knowing how we test these relays, I have my power supply set to 8 volts. These are 12-volt relays. Typically 8 to 9 volts is still okay for testing purposes. My multimeter is set to continuity mode, so it means that it will get a beep when we have a short. So if I check these two pins together, no beep, no beep, no beep, no beep. But if I apply 8 volts here, I just heard it click. And we do have a beep, so the relay is good. I also just heard a click here, and we have a beep. So As I had mentioned, both of these relays are technically good, but knowing that they do commonly fail, we're gonna go ahead and replace them anyways. All right, so here are my brand new replacement relays. We're gonna go ahead and feed them through. And since I only have one hand here holding the relays and the other on the iron, I'm gonna have to try and balance this. All right, and that should be good for now, at least to hold them in. Now I can solder in the other pins. And these over here are the pins where all the high voltages come through. So these guys I'm gonna hang out for just a little bit longer on the joints. As I mentioned earlier, same reason. And these are the 4 original joints that I used to lock them in. I'm gonna add a little more solder, and same thing, hanging out on these joints a little longer. Really making sure we have good contact everywhere. Okay, this does conclude the repairs for the controller board. Now we're gonna do some live testing in our oven. Now, technically, this oven is not the correct one for this circuit board, but it is a very close match on the model number. What we're gonna do here is, because the customer did not send us any of the buttons, I have my own set of buttons that I'm connecting to it. So let's go ahead and power it on. And we're gonna hit cancel. Let's see. I'm gonna go ahead and bake. Okay, and our bake is on. We are set to 350 right there. So we're just gonna wait a couple minutes and double check what our temperatures are at. So we're doing a preheat right now, and we'll be right back. The unit has been running for a few minutes now, and it is still preheating. It just switched to the broil actually. If we open up our oven, yeah, I can see some smoke. I don't know if you can see that smoke, but we're definitely on and preheating. So we're gonna go ahead and clear that off. But that does complete our repairs. If you have an oven controller board that you would like to send in for us to fix, we do offer flat rate services, which come with a 1-year warranty. And that will be on our website, which is linked in the description down below. Otherwise, if you found the content helpful or useful, make sure to leave us a like, subscribe for more, and thank you for watching.